If you like the video, please subscribe Technical PCT channel and click the bell icon to get the latest videos.
Time period of oscillation of a charged pendulum in electric field and in combined electric and gravitational field, right? One important point I told you, whenever both electric and gravitational fields are acting, time period formula T is equal to 2 pi root L by G plus or minus A, right? Just go through your notes. T is equal to 2 pi root L minus G plus or minus A, where A is acceleration due to electric force. What is the formula for that? EQ by M is the formula. And two rules: when we take plus, when we take minus. When we consider plus, whenever gravitational force downward, always downward, and electrostatic force on the body is also downward, both are in the same direction, we take plus there. Whenever electrostatic force is acting upward, gravitational force always downward, opposite those two are, we take minus there, right? This is what we discussed in yesterday's class. Well, today, few small examples. This is a smooth surface, and here is a block of mass m. A block of mass m. This block connected to this rigid support by using a spring of spring constant K. For this spring constant K, the initial separation between the center of the block and here, let this is L. Initial separation is L. Let Q is the charge on the block. Let Q is the charge of the block. So now this block has charge Q. So what is given for us? M, mass of block, Q, charge on block, K, spring constant, L, initial separation between what and what? Between block and wall. This is the initial separation. Well, the question given is, an electric field is applied here in this region, in this direction. An electric field is applied in this direction, then what happens? Let E is the electric field applied. Electric field applied as shown in figure. The questions ask that what is the maximum separation between this wall and this block whenever electric field is applied? First question. What is the maximum separation between block and wall when electric field is applied? Second question. What is this separation between block and wall at equilibrium? This is second question, right? Well, in both the cases, they ask separation only. So what is the difference between this maximum separation and that separation at equilibrium? Just we try to understand. Whenever we apply electric field, as it is having charge Q, what happens? This block, on this block, due to this electric field, a force acts, right? In what direction that force acts? That force acts in this direction because this is a positive charge. It experiences a force in the direction of the field, so it experiences a force. Initially, it is at rest. Whenever it experiences a force, it moves, right? That is the some max work done by the force on the block, so it moves. Whenever it is moving, that work done stores in this spring in form of energy, potential energy. See, let it moves from here to here. This is the maximum separation. I draw the same diagram here. This is L initially. Here it was. Now it moved to this point. This is its initial position. Now this is its final position. It moved through a distance, let x. Already from here to here, L. So what is the work done in moving this distance? Here due to electric field, there is a force acting F. What is the formula for force due to electric field? As this block is having charge Q and field of intensity E, then force due to electric field F is EQ. What is the distance moved? X. Then what is the work done by the electric field? Work done by electric field, W. Work done, force into displacement. What is force here? EQ. Displacement is how much? X. So EQX. See that work done as it is moving, that spring starts expanding. See, like initially the spring is like this, now it becomes, it expands like this. How much it expands? By this distance x. How much this block moves, that much it expands the spring. We know in a spring, whenever a spring is stretched, in the spring, another force develops, restoring force, and potential energy comes in. That potential energy in the spring is half k x square, right? Because the elongation in the spring is same as this block is moved. How much distance this block moves, that much the spring elongates. If k is the spring constant already given for us, then potential energy developed in the spring is half k x square, right? Come on. Potential energy in spring, for my convenience, okay, x let it be. Potential energy in spring, U. What it is? Half k x square. So whenever suddenly this field is switched on, it moves suddenly and it moves maximum till the total work converts into potential energy. So at this position, this work done is converted into this potential energy. So we can make these two equal. From 1 and 2, at maximum separation, x EQX is equal to half kx square. Work done is equal to potential energy. X, 1x get cancelled. From this, what is x? Maximum separation x is equal to 2EQ see here 2EQ by K. This is maximum separation, right? Whenever in coming course also, even in first year in mechanical properties of solids we studied, whenever spring is suddenly stretched, suddenly load is released, what is the maximum separation? You just recall those problems. Wherever maximum separation is needed, we equate energies, right? Potential energy, work done, we equate those two. Wherever maximum separation is needed, right? Next, this is maximum separation. Second question is what? What is the separation between block and wall at equilibrium? I use the word equilibrium. Sir, what is the difference between these two, sir? Whenever this electric field is applied, suddenly it moves in that direction till its total work converts into energy. But what this spring does, that spring, a restoring force develops in and it pulls it back. Due to that reason, it oscillates for some time and comes to rest at a particular distance, like this. Initially, the block is here, and let Finally, after oscillation, that block come here. This is the position of this spring. Initially, the distance between this point and this point, you know, L. Now, it oscillates for some time and come to rest. Let at a distance x naught. What is the difference, you understand? Once field is applied, suddenly it moved back. What is the maximum distance it goes? This much. It cannot stay here. The spring as restoring force develops. How much restoring force? So in this direction, force due to electric field, EQ. In this direction, in the spring, force in the spring, we know Kx. You have idea? K is the force per unit elongation. If x naught is the elongation, Kx naught is the force developed in the spring, which is a restoring force. Restoring force means opposite to this, in this direction. Due to this block oscillates and finally comes to rest somewhere. That position, at that position, this force and this force are equal. That position is called equilibrium position, right? See here, what is the note point? Block oscillates and comes to rest at equilibrium, right? At equilibrium, the elongation of the spring is x naught. See, this x is the elongation, and you are asked what? Separation. Separation means what? L plus x. Here, you write down separation L plus x. Here there is no space, so I am writing it here. Total separation between the wall and the block is L plus x, right? So what is the elongation? X. What is the separation? L plus x. Here also. The block oscillates and comes to rest at equilibrium. So at equilibrium, elongation in the spring is what? The spring elongated by the distance x naught. Then force electrostatic force Fe is equal to what? EQ. Restoring force, where it develops in the spring, that is what? Kx naught. At equilibrium, these forces are equal, right? At equilibrium, EQ is equal to Kx naught. Then x naught is what? X naught EQ by K. That's it. Observe here, maximum separation 2EQ by K. Sorry, maximum elongation. Then here, elongation at equilibrium, x naught, EQ by K, right? And what is the separation in this case? separation L plus X naught. L plus X naught is the separation, right? Sir, is it necessary to do this much of big problem, sir? There is a small shortcut. Whenever force is applied, electric field, due to electric field, force is applied. Maximum, wherever you are asked, 2 EQ by K. Maximum elongation in the spring. Elongation at equilibrium, EQ by K. 2 EQ by K here, EQ by K here. Only these two factors different. Remember this, right? Important problem. Note down or take a screenshot. Well,
students, all of you stop your videos. Virendra,
see, we are requesting you to mute your audios and videos.
R. Balaji, stop your video. It's two.
See, you people are taking these classes not seriously. You don't know the situation. It may go to May, June, July, whatever. After that, you cannot repeat these topics. So you should be careful that you should note down each and everything.
Stop your videos.
Well, next question. One question is like this. There is a block. This is a block of mass M, charge Q. This is ball. This is a block. Initially, the separation between these two is L, separation. It is a smooth floor. Smooth floor. Then an electric field is applied on that in this direction. Electric field is applied on in this direction. Initially it is at rest. initially this block is at rest. Whenever we apply electric field, what happens? It experiences force in the direction of electric field, then it gets accelerated. Then it moves towards the wall. Given that this is hitting the wall, it is hitting the wall. Whenever it is hitting or colliding that wall, that collision is elastic. When collision is elastic, what happens? It moves to the same distance, because in elastic collision, from what height we drop the ball, to the same height it comes. Here also this floor is smooth, there is no resistance, so it hits the ball. If the collision is elastic, it comes back to the same position. Again, due to electric field, it moves forward, hits the wall, and again come back. So the process continues. Means it comes in oscillation. This block oscillates on the floor along this line of length here. Right? The question asked is, what is the time period of that oscillation? Right? So what is given for us? Here, M, mass of block. Q, charge on block. E, electric field applied. How? Towards the wall. Towards the wall, right? Well, then L is what? Initial distance between block and wall. This is the data we have. When electric field is applied, first thing, force on block, F, force on this block, F, EQ, right? Then acceleration of the block, A, EQ by M, already we know. If F force acts on, then acceleration is EQ by M. Towards what? Towards the wall. Block colliding the wall elastically. The collision is pure elastic. Then what happens? Block colliding the wall elastically, it oscillates. It oscillates along the line of length L on smooth floor. This is the situation. So what is the time period? See, what is the time to go from here to here? Length. T is the time. Taken by block to hit wall. How to find this T? See here, what is its initial velocity for the block? 0. Acceleration EQ by M, distance L. What is time? You have a formula, S is equal to ut plus half a t square. U is 0, then L is equal to 0 plus half a t square, then t is equal to 2L by a, that is 2L by a, t square is the root over 2L by a. A is what? EQ by M. L by EQ. That is the time to come from here to here. Time period means what? Time for one oscillation. One oscillation means to go from here to here, again come back to here. Right? To go from here to here, again come back to here, completes one oscillation. So to go from here to here, the time is small t. As collision is elastic, within the same time again it comes from here to here. So to come from here to here, again time is t. Then what is the time period of oscillation? Time period of oscillation, t is equal to 2t. Right? Then 2 into root over 2Lm by EQ. This is time period of oscillation. Right? What these examples tell us? We can link kinematics with electrostatics. We can link springs with electrostatics. We can link friction with electrostatics. See, in entrance, generally we get this type of mix. So how to link the concepts? Come on, note down or take a screenshot. Right. Next one. See application 3. So this is a rough surface. Rough surface. Then wherever rough surface gives, they give coefficient of friction. Wherever rough surface is there, immediately idea should come to your mind. Friction acts there. A block is placed on the rough surface. A block of mass m Whenever electrostatic force is applied, this block experience a force in that direction because it has charge. So a force acts in this direction due to electrostatic field. How much? We know EQ. Block is on which surface? On rough surface. Rough surface, immediately when it is trying to move between the block and this rough surface, there is a force acts which is frictional force. There is a frictional force. As it is trying to move in this direction, frictional force acts in this direction. F. If that block is ready to move, these two forces are equal. If the block is moving, this force is greater than this force. Right? Come on. What question asked in the previous sentence? What you have here? M. Mass of block. Q. Charge on block. E. Electric field applied. F. What here? Frictional force. Whenever surface is rough, immediately what they give? Coefficient of friction between block and the surface. Right? Here, block on rough surface. Rough surface. Then, what is force due to electrostatic force acting on the block? Force due to electric field and electrostatic force on the block? EQ. What is frictional force? We know the formula? Mu mg. From first year, frictional force acting on the block is mu mg, where m is the mass, mu is coefficient of friction, g is acceleration due to gravity. When block ready to move, this Fe is equal to F because both are in opposite direction. Fe in this direction, F in this direction, then EQ is equal to mu mg. From these, they ask different questions. What is E? Such that that block is ready to move. What is the charge on the block? Such that that block is ready to move. What is coefficient of friction? Such that the block is ready to move. Like 3 questions they may ask on this concept. Come on, take a screenshot or note down. Next. This is an inclined plane of inclination theta. Inclined plane of inclination theta. Let this inclined plane is smooth inclined plane. Smooth inclined plane. This is. On this inclined plane, a block is kept. A block of mass m, say charge q, is kept on it. What happens? As it is smooth, we know its weight acts downward. Then if you resolve it into two components, this is mg sin theta in this direction, mg cos theta in this direction, n normal reaction, right? This is what generally. So what happens here? This block moves down. Simply it moves down with an acceleration mg sin theta. The question is, this block should not move. In what direction electric field has to apply how much? This block is ready to move down because it is experiencing force in this direction. These two cancel out, so it cannot move in this direction. It cannot move in this direction. So what it can do? It can move only in this direction. So to stop moving, what should I do? I had to apply electric field in this direction, opposite to this. In this direction, if I apply electric field, then what happens? It experiences a force due to electric field in this direction, right? As it is not moving, means this force and this force are equal. The question what they ask, what is the direction of the electric field to be? Electric field to be applied, how much it has to be? Then, so he is asking magnitude and direction. Direction is clear here. It is along the direction of the inclined plane upward. How much? Equate these two, you get the answer. Right? Come on. Here, from the diagram, force on block along the plane downward. Is what? mg sin theta. If E electric field applied, how? Along the plane upward, then force due to electric field Fe is Eq. In what direction? Upward. So block to be in equilibrium. Block to be in equilibrium. Which should be equal? This one and this one. mg sin theta should be equal to EQ. Then what question they ask? I told you different questions. How much may be the charge? How much electric field to be applied? They ask. So that is the condition, right? Like we can link inclined plane with electric field. Some advanced problems are there in exercise. If they come, we'll do. Right? Okay. Students, so from tomorrow, second track again starts. Then Monday, we come to first track again. See, this situation, pandemic situation may continue. We don't know for 1 month or 2 months. I'm observing some of you are even now not taking seriously these classes. You are in second year. It is your life. We are trying our level best to give the subject to you people. Be serious and feel that you are in the classroom. You note down whatever we are telling. Then once again, if colleges open, we clarify all the doubts. We may have much more time on the day. So please, I request all the students, be serious to the classes. Right? Thank you. Good day.